Hi, everyone. Welcome to section 12.4. This is the remaining of section 12.4. We're going to be talking about percentiles. So when you standardize the tests taken by larger numbers of students, your raw score is usually converted to a percentile score, which is going to be defined on the next slide. So we already talked about a z-score. Now let's talk about a percentile. If approximately n% of the items is in a distribution, we are less than x, then x is the nth percentile of the distribution denoted p of n. So if we're looking for the 20th percentile, we are looking for p of 20, the 20th percentile, p25, the 25th percentile of the data. So we're trying to find where is that location in our distribution. Now let's look at this one. The following are test scores out of 100 for a particular math class. So notice that they are listed in order. They must be listed in order. And how many items do we have? We have 1, 2, 3, 4, 5, 6, 7, 8 times 3. 8 times 3 is 24, 25, 26, 27, 28, 29, 30. So, and the total data values is 30. We're looking for the 14th percentile. So we're going to say, okay, well, what's the 14th percentile of 30? Well, the 14 out of 100, right? That's going to be our 14%. So we're interested in finding, sorry, the 40th, not 14th. It's the 40th percentile. So we're looking for P40. So we're looking for the location, which is the position at P40. So we want to say, okay, 40% of 30 is what value? And that's going to give us the location. So if we're going to do 0.40 times 30, that's going to give us 12. So that means we're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So between 74 and 75. So it's the 12th item. So we pick the 13th item. So since we have 12, it's 12 and then you jump to the next one. So 12, it's the next position after that. So we counted 12 and we get so up to 74. So the next one would be 75. So that position would be 75. Now, if it landed on the middle, let's say like 12.5, then you would have to do the mean between them. So when we're looking to find the 40th percentile, we take 0.40 times 30, that's 12. So we look at the 12th position and then you look at the next value. So you always round up one more value. Now deciles and quartiles are very similar. So you have a D1, which is P10, a decile. D2 is the 20th percentile. D3, so it's in values of 10, 30th percentile. Now, a quartile 1 is P25, quartile 2 is P50 or half, Q3 is P75, and Q4 is P of 100. So they're going by 25s if I'm looking for quartiles. Now it's asking us to do the same, but now we're looking for the 6th decile. So D6 is the same as P of 60 or 60% of the data. So we're going to do 0.60 times, in this case, it's 30. So if we do 0.6 times 30, that's 18. So remember, you're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. The next number, it's 82. So our value, it's 60%. So we're going to take the 19th item. So it's the one after the 18th. The 6th decile would be 82, the number 82. So that was finding the 6th decile. Now, if we were interested in finding quartile 1, we were looking at the 25th percent, 50%. So quartile 2 is also the median. So it's the middle number of the data. Now, when you're finding a quartile for any set data, you're ranked, you always want to make sure you order your data from least to greatest. And then the quartile two is your median. The first quartile is the median of the second quartile two, and the third is the median of all of the values above Q2. Now, finding the three quartiles. So I'm interested in finding quartile one, quartile two, and quartile three. Well, first of all, quartile one is going to say P25 or 0.25, the 25th percent of 30. So then you're going to do, okay, well, P25 times 30 or 1/4 is 7.5, right? So it's 7.5. So you're going to go, we jump one more. So it's 1, 2, 3, 4, 5, 6, between 7 and 8. So it's 7.5. So it's going to be 70 plus 72 over 2. So then we're going to find the median. So we have 70 plus 72, 142 divided by 2, we get 71. So 71 would be quartile one. The 50th would be right half of it. So you cross, cross, cross. So you cross 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then we say cross, 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 cross. So when we start finding the median, right? So it's, we have n to be 30. So if we're looking for half of 30, in this case, it would be like the 15th. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7, 8, 8, oops, 8, 9, 10, 11. And then we say cross, 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 cross. So the median would be between 78 plus 79 over 2. So the quartile 2, so we have 78 plus 79, 157. So it's 157 divided by 2, 78.5. And quartile 3, it's 0.75, or the median of the other data. So then what we're going to be looking for is 0.75 times 30. So if I do what is 75th percent, 0.75 times 30, that's 22.5. So that means 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, and 23. So we're looking right in the middle. So it's 87 plus 88 divided by 2. So then we have the sum between 88 plus 87. That's 175. So it's 175 over 2, which is 87.5. So then we would have to find our quartile. So we found quartile 2, which is the middle numbers, 78 and 79, which is 78.5. So that was quartile 2. And then the 15 numbers, it was 72 and 88. So what I did, they use the median within the median. What I did was, so basically what they did was they used the median and calculated the median afterward. You may also, so what they did that's pretty much is that they rounded. So see how the value we had was 71 over here, and this was 87.5. So this was the rounded version. Same thing here, so they moved to the second one. Now, you can do it, I would accept it using percentiles. You can also use your calculator to find quartiles. Now, in a box plot, what you have to do is that you first find the minimum value here, and then you're going to find quartile 1, and then your median or quartile 2. And then we have quartile 3. And then let me go back here. The median, and then quartile 3. So everything is in a box like this. And then over here, it's your max point. So we have quartile 1, quartile 2, or the median, and the max point. So what the box plot or the box and whisker plot does, it measures the median and the central tendency and the range, the measure of dispersions within the first and the third quartile. So for the given set of data, for the given data set, a box plot consists of a rectangular box positioned above a numerical scale from Q1 to Q3 with the value of Q2 in the middle or in the median, indicating it within the box. And then we have the whiskers. So we wish to construct a box plot for the weekly study times in the data shown below. So the first thing is that we want the minimum point. The minimum point is 15 and the max point would be 66 from the data. So we can 15, 18, 20, 27, 28, 29, 29, 32, 36, 36, 37, 40, 42, 42, 47, 49. So I'm listing them 51, 55, 56, 66. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So N is 20. That's the value. Oops. So N would be 20. So we have 20 data entries. So we first want to find Q1, which is the same as P25. So then we're able to find Q1, Q2. We can also list the data values. So what I can do is I'm going to share my screen. And then we can use our calculator. Calculate 84. So let me go ahead and project that calculator in here in the moment. So what we could do is I'm going to go to Stat, Edit, and I'm going to remove L1, and I'm going to be removing L2. And I'm going to say, okay, 15, I can do 18. I'm going to do 20, 27, 28, 29, 29. Make sure that you're inputting everything correct. 32, 36, 36, 37, 40, 42. So 40, 42, another 42. So we have two 42s, 47, 49, 47, 49, 51, 55, 51, 55, 56, and 66. So it should be a total of 20 entries. And then you're going to go to Stat and then Calc and then one VARS test. Hit Enter. Make sure that you're listing L1 because that is the list that you're working with. And then it should tell you right here. So there's Q1. So if you notice, Q1 is going to be the value 28.5 right here. And then our median or Q2, it's going to be the same as 36.5. And then Q3 will be 48. And of course, our max value would be 66. So then I'm able to do and create my box plot accordingly. So we start with our minimum value, which was 15. I like to put dots right there. And then we have quartile 1, which was 28.5, where it starts right here. See how the box starts at Q1, and then you have your median, which is kind of cut in half at Q2. And then Q3 is 48. And then our last one, our whisker, ends at 66, which is our max value. And with that, we can do our box plot. So we can do it by hand and we can use our calculator. And with that, we finish section 12.5. Now, this is the last section for section 12.4. We'll go over 12.5, which is a normal distribution. In a normal distribution, we distinguish between what is a discrete and a continuous, a random variable. We're going to be applying the properties of a normal curve. We're going to be converting z-scores of normal curve areas. So we're going to look at how the z-scores is proportionate to curve areas, which is in statistics. We're going to be interpreting normal curve areas in several ways. So let's begin by talking about what is the definition of a discrete variable. So a discrete variable can take only a certain fixed values. For example, the number of heads and five towing costs. So there's only 0, 1, 2, 3, or 5. These are the only whole numbers of five tosses, right? So there's at most five heads on five tosses. That's if all of the tosses you get a head. You can have no heads. You can have one head. You can have two. You can have three, but it's going to stop eventually. Now, a continuous random variable can take on all real numbers. So that would be an example of blossoms, right? We say that the range is between 5 to 25. So the range between 5 to 25, there's 5.1, 5.2, 5.5, so on and so forth. So there's an infinitely many ways right in between 5 to 25, which would make it a continuous normal variable. Now, the definition and properties of a normal curve. So a normal curve is a symmetric bell shape. So it looks like this, where you can have symmetry. It looks like a bell shape. So any random variable whose graph has this characteristic, that means it has a normal distribution. So one thing is a normal curve. The other thing is if the random variable falls within this category, it will have a normal distribution on a normal curve. If the quantity is shown as a horizontal axis, so this is a horizontal axis, then there's going to be the axis of standard deviations away from the mean. So these values, these dots, are standard deviations away from the mean, where your mean is right here in the center. And that is called a standard normal curve. A standard normal curve is where they're a distance away from the mean random instead of a random variable. Okay. So look at the difference. So we have S is the standard with mean is 0 and standard deviation 1. So S, this is a standard normal. That means that the mean is equal to 0, standard deviation of 1, right? They're equidistant right here. Look at the mean. The mean is 0. But C, B, and A, they're symmetric. You have symmetry. So A has mean less than 0 and standard deviation of 1. Curve B has a mean equal to 0, but standard deviation less than 1. And C has a mean greater than 0, so it's kind of pushed towards the right. And the standard deviation greater than 1. So these are the different types of normal distributions we can have, but they're not going to be standard. Now, what are the properties of a normal curve? So the graph of a normal curve is a bell shape, again, symmetric about a vertical line through its center. The median, the mean, the median, and the mode of a normal curvature all occur at the center of the distribution. That's why we called it a central tendency at the beginning of class. Now, the percentages of data within some given distance are approximately as follows. So if you have a normal and you have one standard deviation away, the area under the curve is going to be 68%. Now, as I'm pushing towards the corners, second standard deviation away, so this area is now 95% as I'm pushing towards, and then lastly, well, this orange has more data, which is 99.7. So all of the data will lie within 3 standard deviations away. So this is 3 standard deviations away, 2 standards, excuse me, 1 standard or 2 standard deviations away. So that sigma means standard deviation, population standard deviation. So here we have it. So we have the mean is equal to the median is equal to the mode. The distance away from the mean is called your standard deviations away. So if you have one, all of this piece is actually 1 deviation. That's cut in half because you have symmetry. So 1 standard, 2 standard, or 3 standard. That is called the empirical rule. So that is the rule that's being defined as to be fixed. So if it's 1 standard deviation away, 68, 2 standard, 95, 3 standard, 99.7. So let's not forget that. So let's look at this example. Suppose that 280 sociology students take an exam and the normal distribution is treated as normal. So they're already telling us we have a normal distribution. The number of scores falling within 2 standard deviations of mean. So find the number of scores. So remember that if we're 2 standard deviations away, that represents 95% of all data. If we're trying to find how many scores, we're going to take 95% of n, which is 280. That's going to give us a total of 206, roughly about 266 scores are 2 standard deviations away from the mean. So that would be their scores. 266 scores will lie between 2 standard deviations away from the mean. Now, you can have something called a table of standard normal curve areas. So to enter questions that involve regions other than 1, 2, 3 standard deviations away, we can use table 7 dash 7 or table A dash 2, which is our z-scores, or you can use a calculator to find the area under a curve. So the table gives the fraction of all scores in a normal distribution. So that's when you have symmetry, you have positive and negative z-scores. So we're looking for, use the table to find the percent of all scores that lie between the mean of the following data. So you want to find 1.5 standard deviations away from the mean. So if you are 1.5 standard of 1.5 versus 2.62. So see, this is 2.62 and 1.5. So the mean is your center here at 0. So then if we look at, there's our value, there's our z-score, there's our mean. So you're trying to find the z-score of 1.50. Now, what you're looking for, if I share the table A-2. So table A-2 or the z-score table. Let me go ahead and project the z-score table. Let me see here. Trying to project the z-scores. Okay. So let me go ahead and share my screen. So here we have z values. We're looking for 1.50. 1.50. So when we have the z in the z column, 1.5, the entry is 0.4333. So we're looking for 1.50. Now let's see here. If you are above, so the question is asking to find the standard deviations away from the mean. So we're finding this area. So if we're saying that this z-score is 0 and this score is 1.5, we want to find this area. So what we're going to have to do is we're going to find the area of all this minus the z-score of 0. So if we go to the table and we look at the z-score of 1.5, 1.5, it's 0.9332, which is this piece. 1.5, it's 0.9332 minus the z-score of 0, which is half of the data, 0.500. So if we subtract 0.9332 minus 0.500, we're going to get 0.4332, which is the area that we're looking for. So what we're doing is we're using the data that we're given, right? So when we're given the z-score 1.5 and then x bar, that means that your z-score is 0. You find the area of the entire cumulative to the left. It's going to be 0.9332. That's from the table minus the area of half of the data, which is 0.5. When you subtract 0.9932 minus 0.550, we get 0.4332. Now, same thing. Now, even though, let's look at the next question. It's saying we want to find 2.64 above the mean, or excuse me, below the mean. So here we have our x bar, and then we have 2.62. And it's saying, but below the mean. If we're below the mean, that means we're negative. Our z-score is negative 2.62. So we're actually finding this area. So first, we find the area cumulative to the left minus half. So it's 0.500 minus the z-score of the negative point. So we have a negative z-score, negative 2.62, negative 2.62, negative 2.601. and 2. So that's minus 0.0042. So then we're going to do 0.500 minus 0.0042, and that's going to give us 0.4958, or roughly 49% of the data. So make sure that when you're looking at the z-score table, you should be able to read a z-score table. So now we're saying 2.62 below the mean. So this is our mean. This is below the mean, negative 2.62. I'm finding this purple area. But first I have to find the total area of X bar, which is zero point 0.5. And then I have to look at the z-score of this area, which is 0.0042. When I subtract them, I will get the desired region, which is 0.4958. And that's exactly what we get. Now, the next question, what if I'm trying to find the total region? If I want to find the area between two z-scores, well, first I have to find the z-score of 2.555 and of the z-score of negative 1.7. So that means I can look at, okay, well, I can find the total area of this minus this area. So area of 2.55 minus the area of negative 1.7. So let's look at those z-scores. So let's do that together. So the first z-score is 2.55. So positive, I'm going to go over here to the positive at 1, 0, 1, 2, 3, 4, 5. So that's point. So 0, 1, 2, 3, 4, 5. So it's 0.9946. So it's 0.9946 minus the z-score of negative 1.7. So up here, negative 1.7, it's 0.0446. You can also use your calculator to find z-scores. So I'm going to be publishing that too. So it's 0.994 minus 0.9946, sorry, minus 0.0446, and that's 0.95 or 95% of the data of the area. Okay. So let me share my screen again. So we find the region that we're interested in and we get 0.950, which is exactly what we got. Now, well, what if the total area is what we're looking for? There's our z-score. We have two z-scores. So we want to know what happens or how do we find this? And another way to find this is also we can use our calculator. So if this is a normal, I'm going to use my calculator to help me find it. Let's try that. So let's use calculate 84, and I'm going to publish my screen, and I want to find the area in between two different z-scores. So I'm going to go to second vars, and I want normal CDF. So the lower bound is 0.61, which is the z-score. The upper bound is the 2.63. That's where it stops, comma. The mean is 0, standard deviation of 1. So there is our value, 0.2. This is only for a standard normal. So it's 0.2666. So roughly, if I want to estimate it, that's 0.27. So our area would be 0.267. So we're able to find this again with our calculator if we wish. So what I did was second vars, normal CDF. We have the lower bound to be the starting point of my lower z-score, which was 0.61, comma, and then the upper, it stops at 2.63. And then because it's a standard normal, our mean is 0, standard deviation of 1, and then close it. And then you'll get your solution. So just make sure that you're looking at this very closely. Again, you may use your calculator when you're doing your homework and your test, but you also want to be able to show your work. Now, this one's a different one. Let's use a calculator to finding the total area of, now what if it's on the positive side? So look at the z-score. It's not to the left, but to the right. I want to find this area. If you're trying to find this area, you're looking for, notice that the entire area is 1 minus the z-score of 2.14. So what I'm going to do is I'm going to go to my z-score of 2.14 and subtract. So positive 2.14. 2.14 is 0, 1, 2, 3, 4. So it's 1 minus 0.9838. Why do I have to subtract 1 minus? Well, because 1 is the whole probability. It's 100% of the data. So what we did was if I want to find the area cumulative to the right, notice I'm looking for the area to the right. You're going to look at 1, which is the entire region minus the z-score area, which was 0.9838. You subtract. So if I do 1 minus 0.9838, I should get 9838. That gives me the area of 0.0162. That would be the area, just this region. And that's exactly what we have. Now, we can also use our calculator, but that one is going to look a little bit different. So if I want to use my calculator and find approximately the same value, I'm going to go to second VARS normal CDF. Now my lower bound is actually 2.14. My upper bound is a very large number. So 9999999 up to 6 times. So a very large number. And because it goes on forever. And then the mu is 0, standard deviation of 1, close it. And that gives us 0.0162, right? Very similar. 0.01, which is exactly what we got. So that is another way to look at our solution. Now, what is the meaning of a normal curve? In a standard normal curve, the following are three quantities. The percentage are the total items that lie in an interval. We have probability of a random variable lying within an interval, and then the area. So percentage, probability, and area, they're all the same when we're looking at a normal curve. So let's look at this example. Example A, we're trying to find the z values for given areas. So assuming we have a normal distribution, we want to find the z value, given that there's 39%. Now you're given a percent rather than the z value. Now, how can you find the z-score? So you have 39%, the area to the right. So 39%, the area to the right. So that means we can do something else. So now we're going to look at inside the table for 39 or 0.39. So I'm going to go to my table and see how there's the inside the table, there's different values like 0.994. We're looking for 0.39. What value gives us 0.39 or approximately? So it's going to be something negative. So we have 0. Let's go to 0.39. So see how we have some values that approximate at 0.36, 0.4, 0.39. So it should be relatively close to negative 0.2 something. 0.39. So it's anywhere between two values, and that's negative 0.2. Move your cursor up to 7 and 8. So it's going to be roughly 0.28, and it's actually going to be negative. So there's the z-score to be if it's cumulative to the right or cumulative to the left. So the cumulative to the left was negative 0.275, which is rounded. Now we can also use a calculator. So if we look at the table, we look at the area of 0.11 corresponds to the z-score of 0.28. So we have positive or negative z-score. So it depends where we're standing in our standard normal curve. So in this case, we were looking at the positive region. So our z-score was negative. That's if it's cumulative to the left, but since this is cumulative to the right, your sign will change to positive. So it's going to be 0.28. Positive because we have symmetry among the values. Same thing here. Now this one's different because now you're looking for 76%, so it's 0.76 under the table. And that one is going to be the exact value. So what I'm going to do is I'm going to look at my screen. I'm looking for the area of 0.76. So it's going to be above. So it's going to be more than half of the data. So my z-score is going to be positive. 76% cumulative to the left. 0.76 inside. So see how it's anywhere between 0.70, 0.71. So we're going to be rounding this to 0.71. So look at the area for 0.79, 79% of the data. It's inside the value. So it's going to be in between 0.70 and 0.71. So we always round up. And with that, we finish section 12.5. Thank you. Have a good one.